Okay, so let's look at the structure of the atom. So what are atoms made of? Well, atoms, as you may know, contain protons, neutrons, and electrons. So protons and neutrons make up the nucleus, and the electrons circle the nucleus. So what volume of an atom is occupied by its nucleus? So it turns out that it's just 0.1%. Okay, so a very small percentage of an atom is actually the nucleus. And protons and neutrons have the same mass. Okay, so the mass of a proton is exactly the same as the mass of a neutron. But the mass of an electron is much lighter than the mass of a proton. So a proton is 1,836 times heavier than an electron. So what is the mass of an atom? So we have what's known as an atomic mass unit. So one atomic mass unit is 1/12 of the mass of carbon-12. And that turns out to be 1.67 times 10 to the minus 27 of a kilogram. So very small mass, and that mass is known as 1 Dalton. Okay, so here's carbon with its 6 protons, 6 neutrons, and the 6 electrons. In terms of sizes, the diameter of an atom is 10 to the power of minus 10 of a meter, so that is 0.1 nanometers, because 1 nanometer is 10 to the minus 9 of a meter. And for the size of the nucleus, it's 10 to the minus 15 of a meter, which is 0.001 picometers, because 1 picometer is 10 to the minus 12 of a meter. So you might have heard of isotopes. So what's an isotope? An isotope is, well, they're atoms with different numbers of neutrons, but the same number of protons. So the atomic number is the same, but the mass number is different. So this is hydrogen, so it has an atomic number of 1, because it's hydrogen. But you can see there's 3 different isotopes with different numbers of neutrons. So protons plus neutrons here give them different masses. So it happens to be 3 different isotopes for hydrogen. All atoms have isotopes. So cobalt-59 and cobalt-60. Cobalt-59, that's the mass, so neutrons plus protons. 59 is the natural isotope, and cobalt-60 is the radioactive one. And this cobalt-60 is made by bombarding cobalt-59 with neutrons. So we add an extra neutron into the nucleus here. And cobalt-60 is used medically as a source of radioactivity. You might see the mass number here at, not an integer value, but a number like 24.305 in the case of magnesium. And why you get a decimal number here is that the isotopes have different abundances. So for example, if you look at magnesium, so it has 24, 25, and 26 of the isotopes, but their relative abundance is shown here. So most magnesium comes in the form of magnesium 24 with a percentage abundance of 79, and there's lesser amounts of magnesium 25 and magnesium 26. So that number 24.305 comes about by multiplying the isotope mass times the abundance as a percentage, that would be 0.79, and then we plus 25 times this is expressed as a fraction, so 0.1 plus the 26 times 0.11, so that's 11% expressed as a decimal, 0.11. So if you add up those products, you get 24.3, which is 24.305 to be more precise, and that's how you would work out the mass number. So here's the periodic table. You can see that all the mass numbers here have these sort of long decimal numbers here to represent the different relative abundances of all the different isotopes of these elements. So atoms have 7 different characteristic properties, and I've listed them here. I've for a bit of fun, or to help memorize it perhaps, I've written it out as Meccano, something I used to enjoy as a kid. So they possess mass. Okay, so all atoms have mass, as we've talked about. They contain electrons. They combine with one another, so atoms combine with one another to produce molecules. And they have, a bit of a cheat here with the H, they have various properties, as we will see as we go throughout this course, and they attract one another, and they contain positive nuclei, so protons are positive, so they contain nuclei which are positive, and they also occupy volume. So as we've seen, the atom, most of it is occupied by the electron space. We'll hear about a little bit more of that in detail, but a very small percentage of that volume is actually the nucleus.